practice test for Unit 12, Data and Statistics. As always, make sure you show all your work and thinking so everybody's clear that you know exactly what you're doing, and make sure you circle your answers. So let's take a look at number one. Number one has three parts. It says make a scatter plot that has a positive linear correlation, B, a negative linear correlation, and C is no linear correlation. Well, here's what we need if we're going to make a positive linear correlation. We need a line type shape that goes up. So basically anything that goes up from left to right. So anything that would look something like this in roughly a line pattern. So something like that. And negative linear correlation is going to go down from left to right. So anything like this would be totally fine. So I'm going to go ahead and write this down. So for A, any scatter plot you draw that goes up from left to right and roughly a line is going to be totally okay. And for B, anything that you draw for a scatter plot that goes down from left to right in roughly a line is going to be totally okay with that. So lots of different answers for these. And then for no linear correlation, almost anything goes here. Just can't have a linear pattern. So I'm just going to draw kind of a blob of points, something like that, and that's it. No linear pattern here. No linear pattern here. Keep in mind what we were saying earlier. So if we've got a positive linear correlation, both the x and y do the same thing. So as x gets bigger, y gets bigger. As x gets smaller, y gets smaller. For a negative linear correlation, as x gets bigger, y gets smaller, and as x gets smaller, y gets bigger. If there's no linear correlation whatsoever, if there's no pattern to this, as x gets bigger or smaller, it doesn't make any difference. We get the same type of y values, maybe big, maybe small. So keep that in mind as we're going through this next part. It says identify the sets having a linear correlation that is positive, negative, or no correlation. So the first one says the number of days since you baked cookies and the number of cookies in the cookie jar. So I'm going to use some arrows to describe this like we did when we were working on this in the unit. The number of days since you baked cookies, that's going to go up. Once you make the cookies, the number of days that goes by is just going to go up. So it's going to be the first day, the second day, the third day, and so forth. Well, what happens to the number of cookies in the cookie jar? Well, on the first day it starts really high and then it starts to go down. Maybe there's 2 dozen the first day and then only 18 the second day. So it goes down. So as one goes up, the other one goes down. So this is a negative correlation. So that's a negative correlation right there. A person's height in inches and the number of fingers they have. So the height in inches and the number of fingers they have. All right, so as a person's height goes up, what should happen to the number of fingers that they have? Well, I'm hoping that no matter what size you are, old, young, whatever, the number of fingers you have is going to stay exactly the same. So there's going to be no correlation here. So no correlation. No correlation there whatsoever. Number of pages you read in a book and the number of pages remaining. So let's think about this. The more pages you read, the less pages are left. So as you read more pages, then the number of pages that are remaining in the book goes down. So this is a negative correlation right there. All right, get those circled. And outside temperature and the number of people at the beach. So as the temperature goes up, what happens to the number of people at the beach? Well, people like to go to the beach when it's warm. They don't like to go when it's cold. So as the temperature rises, more people would head to the beach. So that's going to be a positive correlation. So we'll go ahead and circle those. All right, let's take a look at number 6. It says use the line of best fit in the graph at right to predict electricity use when the high temperature is 75 degrees. Use correct units. So this is one of those where they kind of did the work for us. They've given us all the information over here. They've drawn a line of best fit and everything. We do need to look at this further and think about what this means. This is the high temperature. So the high temperature for the day was 70 degrees, 80 degrees, 90 degrees, 100 degrees, and so forth. And this is the electricity use in kWh. That's kilowatt hours. So kilowatt hours. So let's take a look here. 75 degrees. It says predict the electricity use. So predict the Y value over here when it's 75 degrees over here. So they're giving us an X value. 75 degrees is going to be about right here. So I'm going to put 75 there and I'm going to slide up to this line right there. That's going to be about right there. So let's think about what this would would be. 75 degrees on the line, it fits in this nice linear pattern, this general positive linear correlation. So about right there, let's come over here. I think that would be 500. So we're going to write down 500, and then the units would be kWh. So we're going to go ahead and circle that right there. Okay, and I'm going to move that x up there so it looks like we had the x. And then we're going to take a look at the next problem. It says use the line of best fit to predict the high temperature when electricity use is 800 kilowatt hours. So on this one it says 800 kilowatt hours. They're giving us the electricity use. They're giving us the Y value right here. So let's say that we've got 800 kilowatt hours. Let's slide over and find out what the line would say. So we're going to slide over on the 800 kilowatt hour line. We're going to get about right there. Looks pretty good. Maybe it's right about there, but let's slide down here. I would say that's going to be somewhere about right there. Now this is 90 to 100, so 95 would be about right here. I'm going to say this is somewhere in between. 97.5 would be right in between. I'm going to say it's a little bit lower than that, so we're going to say 97 degrees. So we're going to put 97 degrees for our guess right there. Again, notice that each one of them are labeled. There's really not a bunch of math work to do here. All we're doing is we're looking at the table and we're making a guess from that. Now, if you wanted to say it's 97.5 degrees, this is just an estimate. Okay, so that would be fine if you wrote something else. All right, done with page 1. Let's go ahead and flip this over to the other side. Here's where it gets a little bit interesting on problems 8 through 12. It says the table shows the weight in ounces of several candles and the time it takes them to burn. So we've got a 4-ounce candle will burn for 34 hours, a 10-ounce candle will burn for 50 hours, a 10-ounce candle, a different one assuming, is 70 hours and so forth. So that's kind of interesting. And it says do these 3 things. So let's make sure that we do all 3 of these. We're going to label the axes, make a scatter plot of the data, and then draw a line of best fit. Okay, so label the axes. So if this is going to be like the x-axis, that's going to be like the y-axis. We're going to do weight, and I'm going to label that in ounces. And then up here, this is going to be the hours that it burns. And make a scatter plot for the data. So I'm going to go ahead and do a couple of these and then make sure we're on the right track, and then I'll turn you loose on it. So 4 and 34, 4 and 34. Now this is 30 to 40, so 434 would be about right there. Okay, we got that one taken care of. 5 and 36, 5 would be right here. 36 would be a little bit higher than that one, and I'm going to go through and finish the rest of them. Here's the completed scatter plot. The only thing that was maybe a little bit interesting was there were 2 that were 16 and 95. So there's a 16 and 95 and another one. So I just kind of made that point a little bit fatter. So we've got the scatter plot. Now we want to draw a line of best fit. Now a line of best fit, I'm going to do a couple of them here and kind of play around. Kind of like we said before, if you can use a piece of data, one of these data points on here, that probably would be best. So I'm going to center my line, start it right here. And I'm going to stretch it out like that. So I'm going to say about right there looks pretty good, because that leaves, let's see, 5 points above there and 4 points below. I think that looks about right. I'm going to go ahead and use that line right there. So I'm going to block that in, and I'm going to adjust this a little bit and make it a little bigger so it looks kind of nice. Okay, all right, there we go. And then I'm going to extend this line like this. Now that's not a perfectly straight line, but it kind of gives the idea. So I'm using this point right here. All right, and another point is this one right here. I've got a point a little bit below, 1, 2, 3, 4, 5 below, 1, 2, 3, 4, 5. Gosh, that's pretty good. Now again, you can draw any line of best fit as long as it pretty well matches the data. Now if I were to put a circle around this data, that looks pretty darn good. It looks like it goes right in between there, so that's pretty awesome. Okay, that's going to be a pretty good line. Now we've got some work to do. We have to go through here and we have to answer these questions. I bet we're going to be finding slope and coming up with an equation with the y-intercept and all that sort of stuff. So it says, pick 2 points on your line and write an equation for your line of best fit in slope-intercept form. Okay, so we got to do everything here. We've got to make sure that we find the slope and the y-intercept. Now, please make sure you remember, you don't have to use 2 points from here. If you happen to draw a line right through the middle and you wanted to make up some points, totally okay. Now the ones that we're going to use, I'm going to highlight these. The ones that we're going to use are 2 and, let's see, we've got 2 and 18. That's the one we're going to use from this. That's the first one. And then the last one, this is that 1695. And that's actually a great point to use on this one because there were 2 points that went through there. So I'm going to go ahead and write those down. We're going to use 16, 95, and we're going to use 2, 18. And as a quick reminder, remember, this represents ounces and this is hours. This is ounces and this is hours. So we're going to go through here, and first thing we need to do is we need to find this slope. So we're going to do m equals, we'll do y2 minus y1. So that's going to be 18 minus 95. And then on the bottom we're going to have x2, so that's going to be 2 minus x1, that's going to be 16. So I'll grab the calculator, make sure we don't make any silly mistakes on this. We've got 18 minus 95, so we get 77, negative 77. That might concern us for just a second. Let's see, and then we've got 2 minus 16. Okay, negative 14, that's kind of good, negative 14. And then we've got a negative divided by a negative, so this is great. Negative 77 divided by negative 14, or if you just know that's going to be positive, so this is going to be 5.5. That actually works out pretty well. Now, I'm going to go ahead and put this over 1, and as a reminder, because this is always a good thing to keep in mind in a story problem, this was hours. So I'm going to put hours right here, and this was ounces. So this is hours and this is ounces. Now this right here is just the slope. So the slope on this one is 5.5. Great number. So we're going to write down y equals 5.5x plus b. And then let's pick one of these to plug in. I think this is probably the easiest one to plug in. So we're going to get 18 hours out of a 2-ounce candle. So 5.5 times 2 plus b. So this is going to be 18 equals, if you multiply that together, I believe you get 11. So let's do 2 times 5, whoops, 5.5. Hit enter, we get 11 plus b. So let's subtract 11. So that means b equals, whoops, b equals 7. Okay, so we had our slope right here. We've got our y-intercept right here. So this is what we're going to write down. We're going to write down y equals 5.5x plus 7, and we're going to circle that. Okay. We do need to write down what x and y represent. So this is as easy as just going and looking up above or remembering what we had right here. X is ounces, or we could just write OZ. In fact, I think I'll do that. Let's just write OZ on there. And of course the y represents hours, so we'll put hours right there. So important when you're using an equation to represent a story problem that everybody knows what x and y represent. So it says explain what the slope means in the context of the situation above. Alright, here's the slope. So I'm going to write this down again, and this is why we kept this in mind. This is 5.5, this was hours, and this is ounces. Well, when we write it like that, you'll notice that what we've got here is a unit rate. So literally what this means is 5.5 hours of candle burn time for 1 ounce of candle. So 5.5 hours of candlelight per 1 ounce of candle, or wax, or something like that. Okay, that's what it means. Okay, let's take a look at the next one. Explain what the y-intercept means in the context of the situation and if it's reasonable. All right, well, let's think about this. The y-intercept would be where it crosses the y-axis. And actually on this one, gosh, that looks pretty good. 0, 7. That's not too bad. So explain what the y-intercept means in the context of the situation. Well, what that means is, so this is 0, 7. This is ounces and this is in hours. What it means is a 0 ounce candle, so 0 OZ candle, will burn for 7 hours. So is that reasonable in the context of this situation? So we're going to say not reasonable. So in a situation like this, I mean, you could make an argument that, hey, I was just coming up with a pretty good line. It doesn't have to be perfect, and you're right. This is a great way to do this line. We could make the argument that, you know what, we know something about how candles burn, and we could have come here and said, I'm going to make this go through 0, 0, and then I'm going to put it as in the middle of this pack of numbers as I possibly can. That would have been just fine. That's not what we chose to do, but if you chose to do something like that, then that would be totally okay. So a 0-ounce candle will burn for 7 hours. Not very reasonable in this particular situation. Estimate the number of hours a candle will burn if it weighs the following amounts. And then it says, do your estimates seem reasonable? So let's check and see what happens here. We've got an 8-ounce candle. So that is the ounces. That is the X that we can give it. X is ounces. So we're going to say Y equals 5.5 times 8 plus 7, and let's see what the calculator spits out here. So 5.5 times 8 plus 7 is equal to 51, so that would be 51 hours. So I'll go ahead and circle that, and then let's do a 22-ounce one. So that's going to be 5.5 times 22 plus 7, and we're going to end up with 128 hours. So this one would be 128 hours. I'm going to come back here and make sure that everybody knows that's an X value, and what we did is 5.5 times 22 plus 7. Now it says, do your estimates fit the pattern in the data? Let's see. Here's our scatter plot, and here's what we came up with. So I'm going to shrink this down so we can see the whole thing. Let's see, this would have been 8 ounces and 51 hours. 8 ounces and 51 hours would have put it, and I'm going to do this a big blue dot. 51 hours would have been right there. Okay, actually it should be right on the line. It doesn't quite look like it, but it should be right on the line. Now what I feel good about there is it is right in the mix of all these tightly packed numbers, these data points that go up. And then 22 and 128, 22 and 128, 22 and 128 would be probably somewhere around right there. It does fit the data pattern. Okay, so I'm going to change back here, and we're going to say both fit the pattern. And what that means is, even though we didn't get a very good y-intercept for our particular line, even though it didn't make a whole lot of sense, it does make it so everything else kind of fits this pattern. So kind of nice that it works that way. So both fit the pattern. I'm going to circle that. And then we do want to keep one thing in mind. You'll notice that 8 was right inside the data that we had, and 22 was just a little bit outside. I'm not too nervous about that, but if they said, hey, I've got a 200-ounce candle or something like that, that's like 10 times as far as anything else on our graph or in our data set. So we probably would want to be a little bit cautious about that. All right, so good deal there. I'm going to slide down, and we're going to take a look at the last part here. It says, people at a movie were surveyed about whether they bought popcorn or soda. Out of 40 people surveyed, 15 of them did not get a soda. There were a total of 23 people who got popcorn, and 8 of those did not get a soda. Complete the tables and answer the questions, round to the nearest hundredth if we need to. Okay, so let's take a look here. People at the movie, they were surveyed about 2 things. Did they buy popcorn or soda? So it's soda, yes or no, and popcorn, yes or no. And out of 40 people surveyed, so that's the table total. So I'm going to put a 40 right here. It says 15 of them did not get a soda. So of the 40 people did not get a soda. So the no soda people were right here. So that's going to be 15 did not get a soda. There were a total of 23 people who got popcorn. 23 people got popcorn. 23 people got popcorn. So the popcorn people, that total was 23. And 8 of those did not get a soda. So of the 23 people that got popcorn, 8 of them did not get a soda. Okay, let's see what we've got here. Is that enough information? Gosh, I think it is. Take a look at this. I'm going to switch to blue on this one. 8 plus what number equals 15? Or 15 minus 8 equals 7. Okay, so that one's 7. 40 minus 23, this would be 17. And let's see what we get if we go this direction. These are little subtraction problems. So 40 minus 15 is 25. Let's see, what have we got here? 17 minus 7 is 10. And 23 minus 8, if you double check me on this, 23 minus 8 is 15. So let's just go through and take a look. Let's do our last little double check. 15 plus 10 is 25. Awesome. I think we've got all these right, but take a look at this. 25 plus 15 is 40. 10 plus 7 is 17. 15 plus 8 is 23. We're in great shape. So we have our frequency table right here. Now we'll come over on the other one, and it says we do have to do a relative frequency table. So here's what I'm going to do. I'm going to do 15 out of the 40. The next one is 8 out of the 40. 23 out of the 40. So we're doing relative frequencies compared to the entire table total. And I'm going to write, whoops, that's a 40. Make that look nice. That's a 40. And 17 out of 40. And we're going to continue doing all of these. So 25 out of 40, 15 out of 40, and 40 out of 40. Okay, I'm going to take each one of these and put them in the calculator, come up with a percent for each one of these. And I don't think anything weird happens because we're going to divide each one of these by 40. So I'll be back in a minute. So I've got all the percents in our relative frequency table. So I've got the answer here and here. So we've got the tables taken care of. We're nearly done. It says what percent of the people got popcorn and soda? Percent of the people got popcorn and soda. So popcorn is a yes, soda is a yes. That's these guys right here. So that's going to be 37.5%. And what percent of the people did not get a soda? Did not get a soda. So we're just looking at the no soda people. The no soda people would be the 37.5% right here. So it just so happens that on this particular one, both of these work out to be exactly the same number. Just a bit of a coincidence there. One cool thing about this is, like I mentioned before, because we're dividing by 40, every one of these worked out to be correct to the tenths place. There's nothing weird that happens here when we round or anything like that. So we always like it when that happens. All right, study hard, do this several times. Good luck on the test.